Okay, in this final part, now we want to be able to display our analysis in PowerPoint. Um, so one of the things I'm going to do is instead of, let's see, so I wanted to return the predictions of, I wanted to be able to return the predictions here. Let me think through this for a second. We have our model predict based off of that. So if I can really just I can just do this. I can copy this or oh, if that comes out as none, I might not actually be able to do that exactly. Actually, how about this? We can copy that if, but we'll change drops to best feature. If the best feature is not equal to none, then we'll drop the best feature, and then we will want to get our y predict based off the model that drops the best feature. Okay, and then instead of returning our minimum error, we're going to be returning our y predict. Hopefully that helps, that works. Or you know what, this is a much simpler way we can go about doing this. Instead of actually trying to do it within the function itself, why don't we just create another block of code where we go ahead and drop these columns. We'll just call drops equal to this. And then we can take this mean squares. We'll print that out. So okay, is that the same that we got here? Okay, so we're importing. I see, I dropped these columns here, and now we're trying to re-import those variables there. So I got a little bit messy with my code, but that's that's all right. Because what we can do is we can go back to this data frame that we have up here, our model output. And I want to add a new column called tuned prediction. And I'm going to set that equal to y predict. Okay. And so you can see that on some of these, it's a lot closer than what it previously was, but for presentation purposes, we're not going to care too much about that because we can then we'll go here and we'll do model oops, model out model dot output, and we'll go to CSV, and then I guess we can just call this data dot CSV, or yeah, data underscore 05 dot CSV. Can run that. Then we'll go from google.colab and import files dot download, and we'll want to download this, and we can run that. Well, that's taking a second to open up. Let me get PowerPoint opened up. Okay. So I'm going to make a graph over here. So I want to make a scatter plot, and I'm going to make a scatter plot of the actual versus the the different predictions. So that brings up my scatter plot. I want the actual to be the x-axis because that's our independent variable here. Then I am going to actually call this straight line, and this is just going to be equal to whatever actual is. Okay, so that's ideally what our data should look like, our error should look like. And then I'll take our error, or actually not our error, sorry. We're going to take the prediction. I want to move this over so prediction is captured in there as well, and then tune prediction so we can see the difference that they had. Okay, so I got my basic graph. Before I go back to scattering that, to saying anything about that, let's just put in some trend lines for these two. As you can see, the error is very minimal. I'm going to format our straight line that we have, which is right now showing up as black. I'm going to go to want to put a solid line between it. Just so we get something straight, I'm going to go and turn off the markers so we just get a line. And maybe, I like black for right now. We can come back to it. So that creates a straight line. I'm also, just to make it a little bit easier to click and grab on, I have 2 points. It looks like 0 and 8 is far this goes. So I'll have a 0 equals 0, 8 equals 8. That just makes our line a little bit longer. And actually, I'm just going to make this line super easy to work with. I do not need all this data here. There we go. Now we have a perfectly correlated line, and we can see how you can see that the red line, it's hard to see. Maybe if I zoom in on the axes a little bit, let me go over to axis settings, axis options. Right now it's 9. The data doesn't look like it really falls outside the range of 7, and what is that? And I'll put it at 0.5, might be a good one. Okay, now how can I make the spread of this as big as possible? Let's see, for this axis, I want to, 9 is way too high as a minimum. Let's also make it as 7. Hmm. Just experiment with this a little bit. What if I make this 6? I can kind of see the error a little bit better, maybe. Let's go pretty extreme, 5. Ooh, yeah, they are really close. 5, maybe keep it back at 6. What if we do like 6 to 3? What does that look like? Oh, that is 6 to 3, and then we make this between 1.5 and 6. Actually, if this is 6 to 3, then this should be on the same axis. We make this would be 3 to 6 as well. Oh, but then we lose. Okay, actually, I like that. That does show the difference between the red line. It's very minimal. But that's completely okay. Um, so I'm going to say dropping, what were those columns that we dropped? Where is he? Dropping pedal width and species and choose improves model performance by, and we want to look at the mean squared error that we got. We're going to use this later on in the present for our key takeaways, so it's better just to get that on the slide. These are Cruise models MSE by, what's the difference between these two? Take these back to that Excel. Oh, that's nice. There we go. Equals this minus this. Okay. Actually, why don't we do this? We'll get a. When you're presenting to management, they often don't know how to interpret these numbers, so it'd be better if we get a percentage. Um, let's see, so this was our initial, this was the difference, so what is the delta divided by the initial? So 16%. That doesn't seem right. Well, actually, 8. For improving it by 2, 2 is 1/4 of 8. So we're minimizing, reduce, okay. So I can use 16%. I'm just going to have to be very decreases. I probably don't want to use MSE in the lead line. I'll just say error by, let's say 16.8. Should I round that to 17? By about 17%. Um, Dropping pedal width and speed and uh, um, you know what? I'm going to keep them pedal width and the species column columns decreases the model's error by about 17%. Okay, that's a good lead line. That is acceptable. Now I'm going to add an, let's get a regression. Actually, I do not know which regression line I'm clicking on. Okay, we know whichever one is closer to 1 is the red. Okay, so this is going to be the red and this is going to be the blue. So why don't I go ahead, first let me get rid of these grid lines just to clean things up a little bit. And also, it might be a good idea. Man, they are both so close. Maybe I'll put this one over here. I'm going to make this, so that's the same primary color. And this is the same color for this. You know, I'm going to add a tread line to our manual tread line. Um, okay, so that gets a pretty good, hmm, maybe this might be cleaner. So that tells you what all three of the different tread lines are doing. Let's also increase the width. Is that? Oh, that's the width of the tread line. Let's not have a line then for that. This is what I want to increase the width of. Let's go to this tread line. Let's increase the width to 3 so that's easier to see. Also increase it to 3 so that one's easier to see. But we are going to change it to dotted lines. Let's make those a little bit closer together. Okay, yeah, I like that a lot better. Okay. Um, Man, I'm still not that happy with how close these are together. And maybe that's the point, though. You know what? I'm not going to spend too much time worrying about it. Let's add some axis titles here as well, just so our viewers know what this graph is saying. So this is pedal, and also, wait, when we need to add this, when predicting pedal length. And that's super important because this is what we are actually, this is the whole point of this model is to predict pedal length. So I need to get that in the lead line. Okay, so pedal length prediction. Pedal length actual. And then, I want to, let's see, if I do legend, um, let me try that. Do you really like any of those options? You know what? I'll just make my own legends. Let's move these down here. Oh, those aren't perfectly aligned. Yeah, I can only select. Okay, that looks good enough. It would have been better if I did it as an external element from the graph. Let me insert a text box. Perfect. Zero error. Error. Before, two, four, dropping, forward, tuning, after, tuning. Let's make that, it's probably like size 12. Alright, and we'll get back to colors. Something like that. How does 13 look? Yeah, that's acceptable. Yeah, it would have been a lot better if I did this outside the graph to begin with. Okay. Oops. I pressed Alt H, Alt F instead of Alt A. So instead of Alt H. Okay, so we're going to want to make this one blue, and then this one red. Maybe move this down a little bit. Okay, that's pretty clear. Okay, I'm in a happy position or what the graph is, where the graph is. Let's see, what was this number? This was a good number to have. So let's state dropping petal width and species Vergina changes from column to features. Features from the iris data set improves prediction or let's do decreases MSE by 0 points. We'll cap it off there. And then we can say something like we have our initial MSE before dropping features of it as this. Final MSE after dropping features. Six, six, nine. We'll round that up to, we're going how many decimal places? 1, 2, 3. So 1, 1, 2, 3. So we'll round that up to 7. 0.7. Yeah, that makes sense. So what is the takeaway? What might be another thing that somebody might be interested in looking at with this? Let's see. So we dropped a bunch of features. We dropped 2 features. That naturally means that one of them is probably more significant than the other. Let me go back to the data set and let me look through it. So we dropped petal width and this species. So we got rid of this column and we got rid of this column. Here we go. We got rid of this column and we got rid of this column. So my hypothesis is going to be sepal length might be a better might be a more correlated to petal length than petal width. Okay. Possible. It's possible that sepal length is more correlated to petal length than petal width. Let's make this, it is possible that sepal length is more correlated to petal length than petal width, and by dropping petal width, it allows for sepal length to better predict petal length. Okay, so this would be great to do some follow-up analysis on. Um, let me want to bold that because that's important. Size 16, 16. Yeah, we can leave it at size 16. Let me take a look at this slide really quick. Dropping petal width and sepal and species. Virginica features decrease the model's error by about 17% when predicting petal length. Okay, it's very clear. We are dropping these features, and if we drop these features, we can decrease our error by that much. When predicting this certain variable. Okay. Um, oh, that might be a little bit misleading. Let me put that back in. Um, that's getting a little bit on the technical side. I'll leave it for the case of this assignment. Also, let's format. Okay, graph looks fine. Only thing that needs to happen really is formatting these axes. Let's make sure that the major is just one. Um, Actually, 0.5 wasn't that bad. Creating slides is really an art. Let's go to numbers. Just make sure that everything is being consistent. We want everything to have one decimal place. I think that was the biggest thing that's thrown me off was some didn't have any decimal places, like here. This is fine. It just needs, um, these numbers need to have the same decimal places. And also, this needs to be bolded to match the other text. Okay, that looks good. You can see that's more closer to 1. I'm going to change this, say 1x. Actually, let's make this the same. That's 1, 2, 3, 4. 2, 3, 4. Okay, there we go. Okay, that is a lot more clear. What we're trying to achieve. Perfect. Okay, so lead line looks good, graph looks good. Let's go over here, dropping petal width and species features from the iris dataset decreases MSE by 14 by 0.014 initial MSE. All good, good. It is possible that the length is um more correlated petal length than petal width, and by so by dropping petal width, let's petal width would allow for sepal length to better predict petal length. That would be a good follow-up and analysis. Okay, that all looks good. And for the footer, put source is going to be I need to change that. The source is going to be the iris data set. Okay, and this is good to go. Now, I just walked you through kind of the process of how to really take analysis like this and turn it into a good-looking slide. I'm not expecting you to go through that much work with your assignment. I just wanted to give you that example of how I would go through and do it. Um, However, it would be, like I said earlier in the videos, just to get the minimum credit for this assignment. It is perfectly fine if you just want to go ahead and do this and explain something. However, if you flip back and forth between the two, you can really see the difference in quality between a slide like this and a slide like that. So if you do find the coding portion of this exercise a lot easier, then I want you to try to focus on making something that would look like this. If you do struggle with the coding, this is completely fine. Um, go for it. Go ahead and turn in something like this. Make sure you just have a good lead line that takes some kind of insight from it and have some key takeaways. But that wraps up this assignment.